Hi, I'm Chris Bidd and welcome to the 5th YOU SYNTH video blog. Last time I promised to talk about RS485 and how it related to YOU SYNTH. Well, originally the idea was to have a central hardware processing unit processing all the signals from all the inputs and producing output at a note level, a MIDI level. However, once I started playing around with RS485 for development purposes, it became clear to me that this was actually the way to go for the whole system. Here we have a picture of a typical YOU SYNTH setup. As you can see, to the right hand side we have a computer. That is connected to the rest of the system via an RS485 to USB interface, and all the modules are connected to that via twisted pair connections. I'm proposing to have just one PCB that performs several functions. For instance, here we can see that PCBs 1 and 2 are processing the input from contact drum pads, but PCB 3 is processing the input from an ultrasonic sensor. In this setup, these boards are basically as dumb as possible. All they do is read their sensors and send the information back over the RS485 to the PC. All the clever processing is done in PC software. This is because it's much easier to write software in a PC than for an embedded CPU. Believe me, I know. And a lot of people are familiar with writing PC software, where not so many people are familiar with writing software for embedded CPUs. As you can see, I've drawn the three PCBs as being identical, which is the eventual plan, that they will be able to perform all the functions that we want the system to perform merely by selecting which components are fitted in certain locations. Okay, so where does all this leave the hardware? Well, as you can see, I've moved the amplifier boards out from underneath the pads so they're easier to get at, and connected the pads to them via screen cable. I've also glued down the pads because they were giving false triggers from jumping up and down. With the envelope detection now happening in the main processor, these boards are just simple amplifiers and half the components on them are redundant. So our YOU SYNTH PCB would now consist of the four amplifiers, a central processor unit. This could be reduced to a single 20-pin chip, and an RS485 interface. This is a cheap one bought off eBay, and this goes via the twisted pair to an RS485 to USB interface. This uses an FTDI chip, which I know and are very easy to interface to. For testing purposes, after much struggling and hitting pads, I decided to inject a signal in using this MP3 player. If I unplug it and turn it on, there, that is some pad hits I simulated in software and just copied across. Right, I'll just quickly run through my little debugging system because it is quite interesting and it did set me on the road to using RS485. Okay, firstly, in my embedded software, I set it to hardware test mode. I then compile and run that. Okay, so that's now running and that's spewing out data at 1 megabaud over the RS485. So to read this, I need this little rectifier test application. So I start that. I open the RS485 port and I set it to input, and that's just telling me it's saving buffers full of data. Lots of buffers. Okay, so that's enough of that, so we'll stop it. It's now processing this data into a more useful format. It's done that. We'll close the RS485 port. Okay, so it's processed the data into a CSV file, which I will now open. Called temp CSV. There we go. We've got 3 columns of data, 3 channels, which I will now turn into a graph. Like this. So we'll have a line graph as lines. Expand it. And there we can see the top is the envelope value, which you can say the pulses are decreasing linearly. This is the max value, which is the output. And this is the min value used for processing. So we can see that the software is working nicely and we're ready to actually make some music with the system. And I'll save that for the next video blog. Goodbye for now.